Assalamualaikum. In today's episode, we revisit Newton's law of universal gravitation, focusing on the resultant force exerted by the sun and the moon on our planet Earth during a lunar eclipse. So join me till the end of this video. Watch and learn. The question is, during a lunar eclipse, the moon, the earth, and the sun all lie on the same line, with the earth between the moon and the sun. The moon has a mass of 7.36 raised to the 22 kilogram. The earth has a mass of 5.98 times 10 to the 24th kilogram, and the sun has a mass of 1.99 times 10 to the 30th kilogram. The separation between the moon and the earth is given by 3.84 times 10 to the 8 meters. The separation between the earth and the sun is given by 1.496 times 10 to the 11 meters. What is the magnitude and direction? Letter A, of the force exerted on the earth by the moon. Question letter B, of the force exerted on the earth by the sun. And letter C, of the net force exerted on the earth by the moon and the sun. So, as illustrated in the figure, we see a lunar eclipse, okay, when the earth is exactly between the moon and the sun, right? So, these three celestial bodies are perfectly aligned with one another, right? So, uh, as given here, on the side of the Earth, right, that is facing away from the sun, okay, they experience or they see lunar eclipse whenever uh, the what you call main shadow of the Earth is cast on the moon. In other words, when the moon happens to be uh, closer to the Earth than the usual distance of the moon from the Earth. All right, but we know that although the moon uh, revolves around the Earth every month, all right, but we don't experience or we don't see lunar eclipse every month, and that is because the orbit of the moon around the Earth, okay, is somewhat deviated or inclined, okay, relative to the orbit of the Earth around the Sun. All right, but in this problem, we're interested on how much force is exerted by the moon on the Earth and the force exerted by the sun on the Earth. All right, when these two forces are combined, what would be the resultant force on the Earth exerted by the moon and by the sun? So we are given, of course, the mass of the Earth, denoted by m sub e equal to 5.98 times 10 to the 24th power kilogram. That of the moon is m's of m equal to 7.36 times 10 to the 22nd power kilogram. And the mass of the sun, of course, m's of s equals 1.99 raised to the 30th power kilogram. And we are also given the center-to-center separation distances. Between the moon and the earth, it is 3.84 times 10 to the 8th power meter. And between the sun and the earth, it is 1.496 times 10 to the 11th power meter. All right, so to compute for the force of attraction of the moon on the earth, we apply Newton's law of universal gravitation, whose mathematical equation is given here. That is, the force of attraction is equal to the product of the constant capital G, all right, the mass of the earth, the mass of the moon, right, and divided by the square of the distance of separation between the earth and the moon. All right, so the constant capital G has a value 6.67 raised to the negative 11 Newton meter squared per kilogram squared. So, if you recall, the universal law simply states that any two objects in the universe are mutually attracted, okay, to each other, and that this force of attraction is directly proportional to the product of the masses of the two particles or objects, but is inversely proportional to the square of the distance of separation between the two bodies or particles. So, when we plug the quantities into this equation, we get the force of attraction of the moon on the earth equals 6.67 times 10 to the negative 11 Newton meter squared per kilogram squared times 5.98 times 10 to the 24th kilogram times 7.36 raised to the 22, all right, or 22nd power kilogram. So after multiplying the quantities in the numerator, okay, we divide it by the square of 3.84 times 10 to the 8 power meters. So with the help of your cycle, we get the value of the force exerted by the moon on the earth equal to 1.99 raised to the 20th power Newton. All right? And this direction, of course, is towards the moon because the moon is attracting the earth towards it. And for question letter B, finding the attractive force exerted by the sun on the earth, we still use the same formula. That is, the force exerted by the sun on the earth is equal to 6.67 raised to the negative 11 Newton meter squared per kilogram squared multiplied by 1.99 times 10 to the 30th power kilogram times 5.98 times 10 to the 24th power kilogram, then all over the square of 1.496 raised to the 11th power meter. Again, with the help of your calculator, we find the force exerted by the sun on the Earth equal to 3.55 raised to the 22nd power Newton. And of course, this attractive force is towards the sun. Finally, for part C, we determine the net force or the resultant force exerted on the Earth. Of course, this is on the assumption that uh, the other planets' attraction on the Earth, okay, are disregarded. So we are only talking about the vector sum of the force of the sun on the Earth as well as the force of the moon on the Earth. That is, the F net is just the difference between F sub SE and F sub ME. That is, this F net equals 3.55 times 10 to the 22nd power Newton. That's the force of attraction of the sun on the Earth. And minus 1.99 times 10 to the 20th power Newton. This is the magnitude of the force exerted by the moon on the Earth. All right, so we finally get the value of the net force equal to 3.53 times 10 to the 22nd power Newton. All right, and since the force of the sun on the Earth is much greater compared to the force exerted by the moon on the Earth, we say that the Earth is being attracted more towards the sun. And that ends our video lesson for this topic. Till the next episode, mabuhay. MashaAllah. Thank you very much for your indulgence. Please don't forget to subscribe